Hi, everyone. Thank you for being here after lunch. And we'll get started. I'm Alolita Sharma. Very happy to be here at DevOps and presenting on open source, Open Distro for Elasticsearch, which is a downstream distribution for Elasticsearch, and also talk about some of the performance diagnostics and metrics that we are actually building out as plugins in the distribution. I'm a principal technologist working on open source and open source projects. Love open source and have been working in it for many years. And I'm super happy to be, interacting and talking with you about the distribution here. I also have a fellow colleague of mine who will also be deep diving into the architecture for Performance Analyzer, which is the component we'll be covering, Adithya, and he'll join me on stage, and then we'll kind of deep dive into different sections. So with that introduction again, how many of you use Elasticsearch today? Cool. So almost all of you have actually been using Elasticsearch, the ELK stack. So what we'd like to kind of cover very quickly is give you an overview of what Open Distro for Elasticsearch is all about. Talk about the Performance Analyzer at an overall level, which is an open source component in the distribution. And then deep dive into the architecture of the different processes that are in the Performance Analyzer plugin. And then walk through some of the metrics that we use and have built and instrumented in the Performance Analyzer, which you can actually use to track the ELK cluster, the Elastic cluster that you have. So as most of you know, and I will not dwell on this, most of you use Elasticsearch. How many of you use Kibana also for visualization? Almost everybody, right? Because Elasticsearch sometimes is used on the back end, but by and large, everybody uses ELK as the ELK stack. And as you know, it's built on top of Apache Lucene. It is using Kibana for visualization and Logstash for ingestion. And for everyone in the enterprise world, at least, Elasticsearch is a very popular implementation which is used and almost in the top 10 of different Elasticsearch distributions which are data-oriented. So why do we care about this? And as we have been working in the search space for a long time, most of us are dealing with logs. I mean, how many of you process logs versus use Elasticsearch for full text? How many of you use logs? Many of you do, right? And almost 50-50. And how many of you use Elasticsearch for full text search? Some of you do. So as you see, the world of search, is very varied. You're looking at data which is coming from different types of logs, and logs are just growing tremendously in number and in size, right? So we continue to accumulate terabytes of logs, log data, coming from our servers, our databases, IoT devices, as we instrument, applications on which are collecting data through IoT devices, and as well as server logs, which are for our AWS or other cloud-based stacks, that many of us use. So in this world of logs, it's super important to have your search clusters, which are used to analyze this data, to be efficient, to be optimized, and to be performant. And this is where Open Distro for Elasticsearch comes in. It's an open source distribution that we released from AWS, which is completely Apache 2 licensed. And it actually provides a lot of functionality that our customers have been using and have requested over time. Security is one of them. Alerting is another aspect, SQL. And again, this is all based on really requests that customers and users that we interface with have been building out for their organizational applications as well as developer-based individual applications. So in security, which is a big area for Elasticsearch users, there is encryption in rest and encryption in flight, which is available, fine-grained access control, audit logging, and compliance that you inherit, which is a big thing for enterprise customers in general. And this is all open source. So that's something that really comes out of the box. And if you haven't checked out, I should ask you now, how many of you have looked at Open Distro for Elasticsearch? Some of you have. So few of you, but you should check it out. It's on GitHub. It's open source. Similarly, there's the alerting modules, which are enabling you to actually be able to alert on the components and the data that you have, and also create monitors for different thresholds of notifications that you can actually do on your data. Then you have SQL plugins, which are available, which enable you to actually not only query the data you have in Elasticsearch, but also be able to run SQL queries. And there are a lot of, at least 40 plus commands that you can run in this interface. And you also have a translation editor for JSON, which you can use. And then last but not least, which is the component that we are deep diving into, is the performance analyzer, which enables you to really track and understand and analyze the bottlenecks in your systems, in your Elk cluster health. And that's what we are going to deep dive into. So each of one of these components is open source. And again, the beauty of that is that you can actually go and look at the code, you can extend it for what you need. And also, if there's a feature that is not available there, you can actually request it. And developers and the community working on it definitely, we take a look at it all the time. So welcome, entering the performance analyzer. And it's again, a performance analyzer specifically built for Elasticsearch. It tracks and works and is built into the process for Elasticsearch itself, and as well as has other components that run in parallel with it. And Adithya will be actually deep diving into the architecture. It enables you, it comes with a lot of knobs, which enable you to understand more about your nodes, the indexes, the shards that you've set up on your cluster for your Elasticsearch application. And also some of the challenges that we were trying to solve with the performance analyzer, from which this has evolved, we use it ourselves, is capacity planning. That is, when you have Elasticsearch clusters, how do you actually plan for how it needs to grow, right? Is it adequate? What the number of nodes you've allocated right now, or the number of shards that you've allocated for it, and there are lots of knobs that you can actually tune, which enable you to really optimize the performance that you're getting out of that out of your cluster. The other aspect that Performance Analyzer does try to address is giving you more visibility into the cluster itself. And that's super important, because at the end of the day, the more you know about the cluster, the health of it, how you know how to optimize it, what are the thresholds that work for your applications and what don't, the better utilization you have of your cloud infrastructure. So some of the use cases that it has been used for by us include identifying bottlenecks for systems resources. And as we said, we consume it ourselves on AWS's services, as well as it gives us understanding about what is the state of hot nodes, indexes, shards, operations for indexing, index state management, searching, tracking system resources, workloads. And we'll deep dive into the types of metrics in each of these categories that Performance Analyzer provides that you can actually go and use for your own implementation. The other area that you really can take away from using the Performance Analyzer is, do you need to increase your system resources based on what is available, what you can see when there is a huge workload that you're processing, for example? Or do you need to scale out? That is, you need to add the number of nodes from what you have currently, or even fine-tune the other metrics that come with it. So with that, I'd like to get Adithya, to come and join us for deep diving into the architecture, and then we'll flip back again into some of the other aspects of the project. Adithya.
Hey. Okay. So yeah, we have three main components. Lot of this came in, we built this, we operate one of the biggest installations of Elasticsearch at AWS. As you know, it's the largest public cloud. A lot of people are running Elasticsearch clusters on our service. And the key thing that we wanted to build was to allow our operators to characterize workloads and also clearly identify whether this cluster is under provisioned, over provisioned. Our customers, Elasticsearch, for some of you who may not know, is a lot like a database, and our customers have multi-tenant use cases where a single cluster is being used by different teams. Each team can have its own table, for example, or indices is what it's called in Elasticsearch, and each index can be consuming different system resources. So it's very hard for someone to clearly provision a cluster, especially when different teams have different resource requirements, and it's something that you can't plan for upfront. So that was the key problem that we were trying to solve. The way we solved it is there are three different components. The first one is we have a plugin, which we call the writer, which sits inside Elasticsearch and instruments. It sits in the critical path. So every single search request that you send, every single write request, the bulk ingest request that you send is instrumented, and we emit events into an event log. And this event log will have events started for every search request, for example. It also tracks every single request that is sent between nodes. So commonly what happens is I'll walk through the data flow, but you have different nodes in an Elasticsearch cluster that communicate with each other through RPC calls, and we intercept these as well, and we emit events. So a big request that you send, which is internally split into small requests, is all tracked. And then we have another component, which is a separate process, which is the performance analyzer agent, or the reader, that you need to run in addition to Elasticsearch. This does most of the heavy lifting. The plugin only writes metrics to shared memory, and this particular process will read metrics from shared memory. It will create metrics for you, and you can pull them out. A lot of times what we've seen is if your Elasticsearch cluster is overloaded, it's really hard for you to understand what's happening with it because it no longer responds to you properly. In this case, the agent is completely isolated. You can run it in C groups, so it'll have much better performance, isolation, process isolation, so you can get your metrics even when Elasticsearch is under stress. And the third part is an easy to visualize tool. This is first tool that we've implemented. This is more of a command line utility that makes it easy for operators to SSH anywhere and run this utility to visualize the metrics that are exposed by the agent through a web API. So here's the data flow. In this case, let's say a customer is interacting with Elasticsearch. He sends in a HTTP request. A lot of times, this is something like a bulk request. A bulk request can have multiple writes or reads. And typically, if you just track the HTTP error code, you only get to know whether the overall request succeeded or failed. You don't really understand what happened inside the request. For example, you may be indexing 100 documents inside a bulk request. So typically, to characterize a workload, we need to understand how many docs per second are being ingested. Out of those docs, how many are being rejected, how many are being accepted, etc. And which indexes are these docs going to. This is what we want to do. So what we do is for every single request that comes in, we have all these events that are being written to the event log. The event log is not constantly written to the tempfs. Tempfs is an in-memory file system that we create. You can also write it to disk if you want to. So we try to group these requests. We have an event queue, and this is flushed every second to the disk to avoid system calls and not affect your Elasticsearch performance at all because it sits in the critical path. In addition to that, like I mentioned, there's an RPC call. So let's say this is a primary shard is in the first node, and then request is sent to the replica to index it as well. So even at the replica, we will then have an event that is generated and returned to the temporary file system, the event queue. So we have the reader, the performance analyzer agent that is constantly polling for update. There's no explicit synchronization again between this agent and the Elasticsearch plugin. It's just based on time. The reader lags in time. So it's constantly polling for updates. It reads the event log, processes all the events that are in the event log. It does correlation. We'll go into specific details on how we generate metrics from those events. But at a high level, for example, if you want a latency metric, if you have a start event and an end event, the latency metric will be the end minus start. So that gives you latency. So that's the kind of operations that we do, transformations that we do. What we have in the reader is a SQLite database that allows us to load and process these events. We on a typical cluster, you can do like 100K docs per second. So it's generating a large number of events. And with SQLite, we were able to do this with very little resource consumption. And this is from the other side. An operator logs in. They SSH into the cluster. They can SSH into their own host, which has PerfTop running and can secure. And it has secure. It's in the network fabric of the Elasticsearch cluster, so it can fetch metrics through the reader API. We also support this feature where a single request to the reader can go and fetch metrics from all the other nodes that have the reader process running. And these are then sent back to the PerfTop visualization tool. So this slide covers the different metrics that we have, different classes of metrics. So customer actions is something that I already talked about. HTTP is all the requests that they're sending. Shard operations are the individual HTTP requests are split into sub-requests, which are shard operations. But we also collect metrics from the operating system. So we collect hardware metrics like CPU, the page fault rate, the disk I/O, a lot more like the networking layer, etc., IP, TCP, etc. We also get operating system on the memory stuff that I mentioned. We get metrics from the JVM, which tells you young gen, old gen, what kind of pauses, etc. The heap allocation rate, which is a key thing. You want to see what is allocating memory on the heap in case you hit a bug in Elasticsearch. We also and then we also have Elasticsearch metrics, which talks about cache sizes, which caches are rejecting data, circuit breakers that are being triggered, a lot of metrics that are available. So going into a little more into what each of these are, the things that I just covered. The main things I missed probably are, you can see page faults if you have too many threads, for example, context switches. We also have like memory used by Lucene. There are some Lucene counters that you can see, like which parts are using what kind of memory. So the next part covers the actual, the key innovation, I would say, that allows us to find these metrics. So the key thing that we do, this is the endpoint that it exposes. What this endpoint lets you do is, what we are asking it is, given a metric called CPU utilization, there are multiple dimensions for it. So for example, now what we allow you to do is get CPU utilization per index or per shard or per node. And this API allows you to specify different dimensions. For example, if you say CPU utilization by node ID, it will give you CPU utilization per node. But if you say CPU utilization by operation, it will give you something else. By operation, like shard bulk, shard search, if you have a cluster where you're running different operations at the same time, You can also have CPU utilization by operation and node ID, in which case you'll get both. So it's like a group by operator for metrics. And you can also do aggregations like sum, min, max, and average. So this is what it comes back, the result of a typical query. So what you can see here is you have CPU utilization for index called NYC taxis, and the operation is shard bulk, which is the write operation, and it's using 13 cores in your system. And you also have shard query and shard fetch. There are two different operations in Elasticsearch. Shard query is the actual operation which queries a particular node. Fetch is it runs on the coordinator node, and it's actually fetching all the data of the different queries that are run on all the data nodes. So as you can see, the query is taking 4 cores, and fetch is not CPU intensive in this case, and it's just fetching 0.33. But you can think about the ways in which, in some cases, fetch might be using a lot of CPU. If your search is cheap, but you're actually pulling a lot of data. So how do we do this? How can you say what operation is using what kind of CPU? So the way we do it is, first of all, we have different events, and for each event we capture which thread the event was executed on. So what we have here is the thread ID 1. We had an operation shard bulk, and its start time was 3. We have an end event. This particular table has clubbed both of them together for simplicity, but we actually have a different event. Start is an event and end is an event. Elasticsearch by itself is a event-based asynchronous programming model. So now we have all these events and the time that they spent on the thread. At the same time, we query the operating system for specific fine-grained metrics per thread. So from /proc, we can get this currently runs only on Linux. So from /proc, we get metrics like thread 1 used 0.24 cores in the last between time 0 to 5. Now what we try to do is correlate the two things. So if thread 1 used 0.24 cores, what were the events that were actually executed on thread 1? Generally, a single thread executes, so we have thread pools in Elasticsearch, so that thread will be executing similar operations. And we evenly attribute all the operations that run on that thread. So now when you do that join, it results in CPU utilization between 0 to 5 was 0.24 cores for NYC taxis for a shard bulk operation. And this allows us to understand which indexes are hot, which indexes are using your system resources, and better provision your cluster. In addition to that, the SQLite that I mentioned, what we do is we create a new database every 5 seconds. It's a complete snapshot. This allows us to rotate the database frequently and also archive it in case we don't want to delete for fleet-wide analysis that we want to do. So the key features, I would say, of the metrics processor, which is actually generating the metrics, is that it's single-threaded. It goes through the event log very quickly. It is not at all CPU intensive. It creates snapshots every 5 seconds. And we have a lot of interesting operations in these snapshots. Like I went through all the correlation that it's doing, but it's also handling like alignment. It's handling missing events. There can be events where it started, but a thread died in Elasticsearch, so you never saw an end event. We don't want to get stuck in such cases. So it addresses all these edge cases. The web service is a really simple one that we've currently written. We're working on improvements. It's an extremely simple Java HTTP server-based web service. We also support encryption in transit for compliance. So even your metrics, where I showed you the visualization tool talks to the agent, and then the agents can talk to themselves. All of that is encrypted. Some of the typical things that we've used this for in the past. One thing that we've used it is for diagnosing disks that are not doing really well. They're doing okay, they're not dead, but they're not doing as well as other disks. how would you identify such a situation? So in this case, we currently expose 3 different metrics to you. You have something called disk utilization, you have the queue size, and the service rate. And what you can do with disk utilization is you can tell whether a disk is being used or not. And so basically, if service rate is 0, it does not mean the disk is bad. But if a disk is being used and the service rate is lower than normal, that definitely means there's something wrong. So that's what it allows you to do, having a combination of metrics. Similarly, this is a typical use case where we have a hot index. The customer themselves don't know what the hot index is. Sometimes you have hot shards. The shards are not evenly placed because of multiple things like availability zones, etc. And this allows you to find those things very quickly. The next step, Performance Analyzer has been around we open sourced it in March. So we've been looking at what do we build next. We have a stream of metrics that is coming in. What we want to build is automated root cause analysis on top of this. How can we build a system to analyze these metrics? What we have is an extremely large number of instances running Elasticsearch. And if we were to collect all these metrics in a single place and try to analyze them, there's just too much data and it's really expensive. What we wanted to build was a framework where we can quickly analyze, aggregate metrics on a node and diagnose node-specific root causes in a cheap and a quick way. And then only move the aggregated data off the node. This was one of our design goals. We have a request for comments that is currently open so that we can get your insights into how you would want to use a root cause analysis system like this. What are your typical issues that you run into with your Elasticsearch clusters? The things that we currently have in mind for our design is, like I said, we want to analyze a stream of metrics. But we also want to do a distributed stream processing on top of these metrics because these metrics are being generated in multiple nodes of the cluster. One way we want to do this is to have like an analysis graph where you would have multiple nodes in the graph, and each node corresponds to a different root cause. Or like, for example, you can have one node that is a Java function that is processing like whether CPU is high, and you have another node that is processing whether memory is in trouble, and then you finally have one node which actually only runs on the master node, which aggregates output of the previous stages and then responds back with what is happening. This, like having an analysis graph, like a directed acyclic graph, where data is flowing, allows us to share data among multiple stages and process streams in a performance-efficient manner. And this also makes it very extensible. Initially, it is through Java functions, but then eventually this graph can be generated automatically via a DSL or something like that. Initially, we are thinking that it will be Java functions that anybody who wants to write root cause analysis component will just write a component and then stitch them together in the graph, and it will be executed by the framework. Finally, PerfTop. This is a Node.js component which runs on the client. You can install it, and it's SSH based. It's easily extensible. We have a JSON format where you can specify what all the panels and the size of each panel, where they are located. It supports different graphs like bar graphs and line graphs, etc. This is a snapshot of what we have. This is for network and memory analysis that we currently have. You can reorder these panels, add new panels like I mentioned. This particular panel is covering garbage collection, for example. You can see how much of the last 5 seconds it was spent in young gen GC, and if that's really high, this is an easy root cause to say that your garbage collection is not healthy, and you probably have to tune your GC settings or your heap size. We won't go through the demo for now, so Alolita will probably.
Okay, so again, we went through a lot of detail. And one of the things, because this is all open source, so you can go and download the source code, as well as the artifacts that are available on through the project website, opendistro.github.io. So you can just go and download the performance analyzer. And also download the node component from NPM, which is PerfTop. And again, I'd love for you, you to give us feedback. It is an open process. You can file issues or comments. We have a community repo where you can actually come and ask for different features, or as you implement it, or use it on your own Elasticsearch cluster. We'd like to hear from you as to what your scenarios are, and are they being supported by the tool or not. And of course, if you have code that you'd like to contribute, would love for you to participate on the project. Here are some of the URLs that are interesting around the project. You can take a photo of it for your reference. So the website again for the project, opendistro.github.io. Discussion forums where a lot of people using Elasticsearch clusters come and ask questions and really help each other, as well as give us feedback on our discussion forums, and as well as on the code itself. If you're finding an issue or tracking a bug, you can come and report issues or file one yourself. And the performance analyzer code, again, specifically is at github.com Open Distro for Elasticsearch. And the project technical documentation, again, people contribute to the documentation. It's available. It's quite extensive. But again, if you find something missing, just tell us. We'd be happy to add to it, or you're welcome to also contribute to the project. Again, every search stack, every open source project, the success of it always matters and is based on community contribution. So we'd really love for you to contribute and participate, even if you're an expert on tuning different parts of Elasticsearch. Come join in. There are lots of folks, like-minded folks who are participating on the project. There are areas that we actually get feedback from our customers or our users on, where we are looking at extending the features, right? And it is an open project backlog. You can actually either contribute to some of these ideas that we have gotten and we maintain as issues on the performance analyzer backlog, such as publishing metrics to the Elasticsearch index. We have actually been working on this, so this is now available. Then visualization via Kibana is another request, that people say, hey, you're doing an node-based CLI client. How about visualization through Kibana? A framework to support metrics ingestion through MetricsDB, for example. So again, different integrations that folks need or have implemented on their own. So I'd like to kind of have it on the project itself. Reader API enhancements. So these are some of the examples of requests that different users on the project have made. And additional health metrics. If there's something that's missing that you think would be pretty cool to add into the project, and make available, just tell us. And then that's, again, the beauty of working in open source, that we all work on, and on making the tools that we use on a regular basis better. So with that, I think we have about 15 minutes left, and we can do questions. You can, again, needless to say, Amazon Elasticsearch is the service that Amazon provides, AWS provides. But what is really cool and has worked out very nicely is that as we build features in the open, on Open Distro for Elasticsearch, that also that innovation also goes back into the production service. And that's really cool because it is actually development happening in the open with your feedback, with user feedback coming in, users actually implementing and contributing code back, even partners working with us closely in this ecosystem to be able to contribute code back. And for example, the alerting component or SQL are already in the service, and the code is available on Open Distro. And there are new features that are coming out, such as index state management, which is super useful and interesting to all of us who work on Elasticsearch applications. Machine learning components like KNN and other components that are coming in. So that's super, super interesting. If you're interested in participating on this code base or giving us feedback on features that you'd like to see, there are open RFCs that are open on each one of these areas, and I'd like to welcome you to kind of come in and participate. You can ping me anytime. My contact is here, Alolita, on Twitter or on GitHub. And again, if there are features you're interested in, we get feedback from all kinds of different sources. Users, customers, partners, folks who are using and developing with Elasticsearch. So come join us, and with that, we can open up for questions. Thank you. All right. Are there any specific questions that anyone has? You can always, again, you don't need to ask me, but again, it's something that you know where to find me. If you have questions later, just come and find me on Twitter or just email me. All right. Thank you again, and appreciate it.